Have you ever really stopped and wondered how the device you're watching this on actually thinks? I mean, how does it take our messy, colorful human world of words and pictures and make any sense of it? Well, let's dive right in, because the answer is actually way simpler and, frankly, more beautiful than you might think. So let's start with a really common question. How in the world does your computer understand this? It doesn't have a face. It definitely doesn't understand happiness or laughter. It doesn't get the joke. So what is really going on under the hood when you send a simple emoji? To figure that out, we have to get to know the machine itself. You have to realize that at its heart, it's basically a foreign entity. It doesn't speak our language, so literally everything has to be translated for it. And that's it. Seriously, it's a world of pure black and white. A tiny switch inside can either be on, letting electricity flow, or it can be off, stopping it. Every single amazing thing your computer does is built on top of this one incredibly simple two-state reality. Now, our guide for this whole journey, our roadmap, if you will, comes from this great introduction to digital representation. We're going to be touching on how computers see numbers, text, and even images to get the full picture. So the big question is, how do we get from our super complex world of symbols and ideas all the way down to a simple on or off? Well, the very first step is to create a kind of universal code, a way to turn every single character into something a machine can start to work with, a number. Think of it like a giant universal decoder ring or a dictionary for everything. Before a computer can do anything with a piece of information, it first has to look up the symbol you typed. Doesn't matter if it's the letter A or an emoji, and find the one-of-a-kind number that's assigned to it. You know, this dictionary has gotten bigger over time. The early systems like ASCII were great for English. They'd assign the letter A the number 65, for example, but they were pretty limited. To include all the world's languages, not to mention all our beloved emojis, we needed a much, much bigger dictionary. And that's Unicode. In this universal standard, our little laughing emoji gets its own unique ID, the number 128,514. Okay, so we've turned our emoji into a number. We're getting closer, but a computer doesn't understand the number 128514 any more than it understands a picture of a face. We need to go one level deeper, down into the machine's actual native language. And that native language is called binary. It's a number system that has only two digits, 0 and 1. So forget everything you know about 1 through 9. In the computer's world, every single number you can possibly imagine can be written using just these two symbols. That's it. So why binary? I mean, why go through all that trouble? Well, this is the really elegant part. It's because it maps perfectly to the physical reality of the machine. An electrical switch that's on represents a 1. A switch that's off represents a 0. It is a perfect one-to-one translation from a math concept to a physical thing. And the processor in your device can flip billions of these switches every single second. Counting in binary, it looks a little weird at first, I know, but it follows a really simple logic. Each position, moving from right to left, just doubles in value. You have the 1's place, the 2's place, the 4's place, the 8's place, and so on. So the number 1 is just a 1. To get to 2, we put a 1 in the 2's column and a 0 in the 1's, so 1, 0. 3 is just a 2 and a 1, so 1, 1. And 4 is a 1 in the 4's place. Using this simple system, you can build literally any number imaginable. So we've gone from an emoji to a big number all the way down to a long string of 1s and 0s. Now, let's build our way back out. How do these super simple digits combine to create the rich, complex files that we use every single day? The final piece of the puzzle is the rulebook. Different file types are just different sets of rules for how to read these long strings of 1s and 0s. A text file, that's just a simple list of those number codes, one after another. But a JPG image is way more complex. It's like a detailed map where streams of binary numbers tell the computer the exact color of millions of individual pixels. And an MP3 file, that's a blueprint for sound, with numbers that describe the precise shape of a sound wave thousands of times per second. So let's put this all together and look at the whole journey from start to finish. Because this isn't just computer language. This is the secret language that's building our entire digital world.